there you go. So I have a line drawn on this page here, and I'm gonna give my line a couple of points. So A, B, and then C. All right. So how do we, in geometry, label and talk about this line here? How can we do it? Yeah. What do you think?
Line ABC.
Yeah. Okay. You're really close. That is not what I wanted, right? We just call this line AC. That'll work, right? Line AC. Will that work? That'll totally work. Okay, that is line AC right there. That's how we could describe line AC.
It's like from beginning to end.
Yeah, right? What can I say about point B? Yeah, point B is not necessarily in the middle, but it's just in between. There you go. So we say this. Point B is between A and C. So therefore, what could you say about point B? It must be where? In what? There you go. So therefore, point B must be in line AC. Right? If I have A, B, and C, and I know this is line AC, and I know that point B is between A and C, then therefore I could definitely say point B is in line AC. You guys cool with that part? All right, good. So that's a line, all right? Let's talk about, this is the same box here. The next thing I want to talk about is not necessarily a line, but a line segment. Whoa, where'd you go? For some reason it's pink, okay? And here we go. Let's make it black. All right, so what's the difference between what I have up here and what I have down below? If I call this A and I call that B, and actually I'll go over here and I'll call this C and I'll call that D, right? Yes, so this up top is a line, this is a line segment. All right, so this is a line segment. What is different between this one and the one above it? What do you guys notice?
This one ends.
This one ends, yeah. A segment is just a portion of the line, right? And what's the difference in the drawing? There's no arrows, yeah. So this is what we call a line segment, and I'll put that down right here. This is a line segment, and we can call this line segment AC, and notice the way I write line segment AC. What's the difference between the little picture above AC? There's no arrows. So that indicates that I'm only talking about a segment, line segment AC. So there's the difference between the two. So check this out. I'll shrink it so we can see the difference. Let's talk about this picture now. This is a ray. What's different between this one and above it? What do you think?
One side is going on like infinitely and one side stops.
One side's going infinitely, one side stops. What do you think, Eckel?
Oh yeah, I was just gonna say one. Just one. It's going like one way. It's not going both.
Yeah. Okay, cool. So it's going in one way. It's going in one direction, right? Yeah, this is a ray. And we can call this ray, we call it AC. Ray could be AC. And we are extending in one direction. Could I also call it AP?
Isn't
No, not necessarily. Mm-hmm.
So the one above it could be line AB.
Line segment AB, yeah. Uh-huh. Could be.
So you don't
Doesn't necessarily
have to
matter.
do from end to end.
Nope, not necessarily. But there is,
For a line run.
what's that? Something very special about this point right here. What's special about that point right there? It's an end point, right? Yeah, this is an end point of a ray. That's where it starts, right? So what does that make these points over here for the line segment? What do you think? Those are also end points. It's the point at which the segment ends, or it's the point at which the ray has an end, right? So a ray goes on for an infinite amount in one direction. Includes all the points. Okay, so take a look at that. What does that look like to you?
A line.
It looks like a line, right? But I'm telling you that this is opposite rays here, okay? So what I mean by that, we have to add a little more to this picture. So if I give you a point over here, we'll call this R. I give you a point over here, we'll call this S. And I give you a point over here, we're going to call this T, okay? Then I'm going to say this. I'm going to say SR, ray SR, and ray ST are opposite rays. What do you think that means? Whoops. So it looks like a line, right? But they are two rays in opposite direction. Do they share anything in common?
Yeah, S.
Yeah, they share a point S, right? Yeah. So that's the end point, right, to those opposite rays.
You want to say they're on the same line now?
Yeah, I could say SR and ST are opposite rays if S is between R and T, right? So we'll finish up our sentence here. SR and ST are opposite rays if S is between R and T. How about it? Anything? Tell me something about the number line. It's got numbers on it. I like that. What else? It's got negative and positive. What else? Extends infinitely. Starting to sound familiar, right? Okay. Well, the cool thing about the number line is there's a relationship here. So what am I doing here? I have a number line, and these lines have numbers on them. But I can also assign what to these numbers? Points. Very good. So I can say this. I could say every point is paired with a number, and every number paired with a point. Right? I compare the point C to number 2. Right? I can pair these together. I could pair number 4 with point D. You guys go with that part? Does that make sense? Okay. So this right here, doing this step, this very, very simple basic step, allows us to talk about length. This is why we do this. This allows us to talk about length. So now I could ask you, what is the length of line segment JC? It is how many units would it be? Yeah, okay, how do you do it? You just simply count, right? From J to C. So I want to go from there to there. Whoops, kind of far. So from here all the way to here. I got 1, 2, 3, 4. So this would be 4 units. So there is a reason why we have this number line paired with points and numbers and vice versa, because once we do that, then we can actually talk about distance. If I did not have those numbers there, right, if I didn't have a scale there, could you tell me the length? No, couldn't do it.
Yeah, above the JC.
It's a line segment. It's a line segment, JC, the length from JC, line segment, JC. So that's labeled correctly. Do you guys agree? Huh? Yeah? All right, cool. All right, the ruler postulate is so basic, you're going to be like, why are we even talking about this? But we're going to cover it really quickly. So the ruler postulate says this. Once we do two things, okay, once points are paired with numbers to form coordinates, okay, once this happens, once points are paired with numbers to form coordinates, then the distance between two points is the absolute value of the difference of the coordinates. Now, this seems so overly basic that we're just going to cover it super quick. So check this out. I'm going to give you a number line, and I'm not even going to give you all the numbers on that number line because it'd be way too many. I'm going to give you this. I'm going to give you this point over here. Call this B. I'm going to give you this difference of the coordinates. Yep, and you're going to see what I mean right now. If this is 0, I'm going to call this -10, and I'm going to call this 7. According to the ruler postulate, what would then be the length of A or BC? Yeah. According to the ruler postulate, length of line segment BC would be the absolute value of the difference of the coordinates, right? So it would be the absolute value of -10 minus 7. The absolute value of the difference of their coordinates, right? This part means the difference, and then their coordinates, -10 and 7. So that's the absolute value of -17, which of course is 17 units. I'll call this line L for right now. And I have 3 points on the line, right? So I have segment AB. You guys see segment AB? Cool with that? And do you guys also see a segment BC? You guys see that? If I add those two segments together, what do you think I get? Segment AC. Boom, you understand the segment addition postulate. Alright, congruent is one of those words that comes up a lot in geometry. And it comes up so much that they have to have a symbol for it, right? What is this symbol right here? Equals. We all know that one, right? That's the equal sign. The congruent symbol is really, really close to the equal sign. We add a little squiggle on top. So this symbol right here is the symbol that we're going to use for congruent. Now, congruent means two things, and it will always mean two things, and these are the two things that congruent means. It means same size, and it means same shape. Alright? That's what congruent means. They gotta be both. Same size, same shape. So you're gonna hear me say, what does congruent mean? You guys are gonna say what? Same size, same shape. You gotta have both of those things right there. Same size, same shape. Okay, so let's talk about a congruent segment. A congruent segment. So if I have this right here, and I have that right there, okay, and I call this DE, and I call this FG, and I say this is 4 centimeters, and I say this is 4 centimeters. Alright, so check this out. Are these congruent segments? Well, do they have the same shape? Yeah, they're both line segments, so that's kind of like a duh. They already have the same shape, but are they the same size? They may not look it, but they're labeled that they are the same. 4 centimeters and 4 centimeters, right? So we say line segment DE is definitely equal to line segment FG because they have the same size. But also because there are line segments, and line segments have the same shape, and since line segments don't count on thickness or anything like that, we can also say this: DE is congruent to FG. What's the length of AP? 1, 2, 3. Is it 3 units? You guys cool with that? What's the length of PB? There you go. Alright. So we can say this. We can say AP, line segment, is equal to line segment PB. You guys agree with that part? They're equal to each other because they have the same length? Do they have the same shape? So therefore, AP is congruent to PB. You guys agree with that part? That implies that P is what? The midpoint. Of what segment? AB.